Very good morning. Welcome to today's Unit 3 class. Okay. I hope all of you are keeping fine, doing good. Guys, the plan for today is until 10:15 we'll have our class. We have the last part of part 3 remaining to complete. We are looking at real life examples of how big data is being used. Okay. So I have a few videos to show you all there. Okay. Nothing much over there, just a few videos and explaining to be done over there. Then if we have time, we'll do a few past paper questions and then take our break. And then when you guys come back, I'll explain the instructions on how we are going to do today's quiz. Okay, today's quiz, it's the first time I'm trying it using Google Forms. So we may have technical issues. We may have certain technical issues which we will deal with when it happens. Okay. All right, everybody, I'm going to share my screen then. So everybody, if you can come down to page number. Normally we do a revision before we get started, but today I'm going to directly start with the lesson. Okay, everybody, can you come down to page number? Let me tell you all the exact number. We had the last part of where big real life examples of where big data is being used. So we came to page number. What's the number? Page number 15. Yep. Okay, everybody. The use of big data by individuals, organizations, and society. Okay. Can you guys first read that paragraph to yourself? It's just introducing what we are going to talk about right now. Everybody, can you all just read that first paragraph? Guys, girls, everybody. Okay, so slowly by slowly, every part of your life, somewhere or the other, it's being connected to the internet. Okay, almost every aspect of your life, pick a part. Okay, if you're lucky, it might still not be connected to the internet, but almost every component of your life, somewhere or the other, the internet is collecting data about it. Internet meant digital devices are collecting data about it. Okay, everyone okay with this? So can you guys read this? So because so much of data is being collected about you, about your movements, about your interest, about how you're spending your time, about what you're expecting. Okay, because so much of data is being collected, companies, organizations are able to better serve you because they know exactly what you are interested in. They know exactly what are you gonna have to deal with in the future. You guys okay with this? I told you a bank is continuously monitoring how much of money is coming into your account. They know how much your company is paying you. They know how the company has kept increasing your salary, because every month your salary is coming to their bank account now. Whether you get a bonus also, it comes into their bank account only. So they are very closely monitoring how you're earning. Based on that, they can also make a prediction. They can make a prediction, you know what, in 10 years time, this person should be earning so much. Based on those predictions, they will make certain preparations. Like what? They would offer you a credit card. They would say, you know what, this person can actually afford a credit card. Okay, they would offer a credit card to you. Or for example, they notice you're somebody who's regularly going on holidays. Then they would say, you know what, we have a pool of customers of, I don't know, 1,500 customers who are regularly going on holidays. So as a bank, we need to partner up with these hotels so that we can give them offers so that they remain loyal to our bank. You get my point, guys? Why do we stick with the bank? It all depends on the offers, right? When they give us good offers, we stay with that bank. So a bank can decide on what to offer customers based on customers' purchases. Is it clear? Then, for example, they have been monitoring your income. They have been monitoring your age. They now know you have got married. They now know you're having a kid. They now know you're going to be looking for a house. You're going to be looking for your apartment. So now they start approaching you for a house loan. Is it clear, guys? It's not like randomly they picked you. No, they have been monitoring your income for so many months or so many years, and now they are approaching you. Everybody okay with this? It's not something random that they are doing. They have been preparing it for a very long time. Okay. Anyway, can you guys go through this? We spoke about the healthcare department, guys, of how they use big data, number one, for personalized treatment plans. Every patient doesn't get the same treatment for the disease, for the same disease. Many people can have the same disease. Let's pick up COVID. You can have a hospital of 1,500 patients having COVID, but each one, the way they get treated will be different. Not treated, the treatment. The treatment that each patient gets could be different. How did they come up with this treatment plan? By analyzing past data. Previously, patients who had this disease in this age group, when they were given this particular medicine, this is how they reacted. Everyone okay with this? So the treatment plan they give you is based on past data. Okay. Then, for example, accelerate drug discovery and development. Okay. Can you guys read that paragraph over there? I want to show you a video also there. By analyzing large amounts of data, doctors can identify trends or patterns in which drugs and treatment proved most effective. When this medicine was mixed with that, when this ingredient was mixed with that and given to this patient of this group, this is how it reacted. Okay. And so based on that data, they can decide, okay, which drug should we go ahead and produce. Okay. Everybody okay with this? Then guys, to track and manage public health threats, the best example I can give you all is COVID. Okay, so guys, remember at one time, now it might be a little difficult for you all to relate to, but can you guys go back to the COVID days when we were all just not sure what to do next? It was like the world was coming to an end, right? All we were hearing was about deaths. This one died, that one died, that one died. Is it clear? We were only hearing about deaths, and then to make things worse, we couldn't even go out. We all had to stay at home. And not only stay at home, we had to all cover our faces and isolate from each other, and no traveling and no socializing. And it was something that we were just not used to, right? So many countries, they started coming up with systems on how they can curb this disease. You know what curb this disease means? Restrict it, bring it down, take control of it, and get rid of it. Okay, so I'm going to show you a few videos. We'll start off with which country? Singapore did. And you all tell me at the end of the video, what do you all think about it? Now, you all might think these people are overreacting. Okay, I'm going to show you a video. You all might say these guys are overreacting. Okay, but you need to take yourselves back to COVID time when we were all not sure what to do next. When we were all worried, scared, confused. Okay, at that time, these measures made sense. But now when we know that, okay, COVID is not so bad as we thought it was. Okay, and now that we have come out of it, this video might look like as if, they're overdoing it. Okay. Anyway, I'll just watch it and see how big data was used to curb this disease. So I'm going to go down to, where is Edge? Edge is over here. And let me put the video over here. Guys online, let me enable sound for you all. But last time when I enabled sound, I had a lot of problems with the microphone. This is not the first time. I want to first show you all this. I want you all to first see, or should I show you all this? I'll show you all this first. And then show you this. See what Singapore did. Okay, so they told everybody they have to install an app called TraceTogether. Now I'm only showing you Singapore and South Korea, but many countries had their own apps. Okay, each country had their own way of dealing with it. How did we go to that video? We came into that video under how big data was used to track and manage public health threats. Okay, right. Can we move on to the next one? Infrastructure planning. So if you take a city, if you take a country, okay, can you guys go through that paragraph over there? Town and city infrastructure involves a wide range of resources and services, from roads and public transport to management of utilities such as electricity supply. The use of big data helps improve the quality and efficiency of these services. Okay, right. Can you guys go through this? Using big data, we can carry out something called predictive maintenance. You all remember the three types we had? Looking at what three types of analytics we had. Looking at past data and understanding your situation was known as what analysis? You're looking at the past. What have we done in the past? How many customers we served? How many are repeat customers? How many only one-time purchases? How many of them are loyalty customers? Descriptive analysis. Looking at your past data is descriptive analysis. Looking at your past data and then making plans for the future is your predictive analysis. Not plans. You come up with stats for the future. Based on your past data, you start making predictions of how you will perform in the future. Predictive analysis. Then guys, you look at your past data, you look at your predictions, and you start making preparations for it. This is known as prescriptive analysis. It's a mix of both. Okay, right. So guys, over here we're talking about predictive maintenance. You see your situation and then you tell yourselves, okay, based on the numbers right now, we will have to, redo the bridge or repair vehicles or put a vehicle in for service. Everybody okay with this? Can you guys go into predictive maintenance? Big data analytics can be used to predict and prevent infrastructure failures. I'll give you guys a very simple example. Many of the modern vehicles, it can warn you when your vehicle is due for service. You all know about that? It will show you a light. Okay, check engine light is on. Have you guys heard about that? You have something called a check engine light. Certain vehicles, guys, especially electric vehicles. No, electric vehicles don't have a service actually. Some of the modern vehicles, guys, they would actually tell you in how many kilometers should you be going for a service. Are we all okay with this? Let's take it to the next level. Imagine you're a fleet operator. You know what's a fleet operator? You're managing multiple vehicles. Take Kangaroo Cabs. Kangaroo Cabs owns many cars. Is it clear? You can't depend. Now, the driver doesn't own the car now. You can't expect the driver to monitor when the service needs to be done. You can't do that. So instead, you need to have a system that will automatically notify you when a specific car's service time is due. Everyone okay with this? So you can then use big data and systems to manage these cars, monitor these cars, and then inform you when service is due for each and every vehicle. Is it clear? So you would have a variety of sensors in these vehicles. These sensors will keep collecting data and sending it to you. And then the system will use this data from various sensors to determine or predict when the car should go for service. Everybody, are you all following with me? This is known as predictive maintenance. Keep reading it, guys. By analyzing data from sensors, from monitoring equipment, even from past data, okay, predictions can be made for when maintenance and replacement of vital systems and components will be required. Okay, guys, online. This enables, you know what proactive means, right? So normally as life advice, we tell people be proactive, don't be reactive. Many of us, we are reactive, including me. After something happens only, we decide what to do. Is it clear? After we mess up the exams, then we decide, oh, what do I do now? Everyone okay with this? We go, we sit for the exam, mess it up, and then we come out of the hall and we start panicking. What excuse do we come up with? Isn't it? That's reactive. You're reacting to the situation. What would a proactive person do? He knows the exam is coming up. He knows he needs to prepare for it. So he would start preparing for it. That's a proactive person. You prepare for events. A reactive person is event happens, then he decides what to do. Okay. Similarly, proactive maintenance is what? You know this vehicle will require maintenance. So how are you going to deal with it? You come up with a plan. That's proactive. You are preparing for the event. Okay, can you guys keep reading it? This enables proactive maintenance, allowing actions to be taken before serious issues occur. Okay, therefore reducing downtime and extending the lifespan of critical infrastructure components. Boys, girls, are we all okay with this? Okay, shall we keep moving? Traffic management and urban planning. I tried to find a video for this, but I just couldn't find a short video. All the videos were long explaining their systems. So guys, nowadays, if you take Google Maps is a good example I can bring forward. Okay, Google Maps is constantly tracking your location. Google Maps can now tell you on average at this particular time how busy this particular road would be. It has collected so much of data. For so many years, it has been collecting data that now it can give me an average number saying for Tuesday, not Tuesday, today's Thursday. For Thursdays, between 10 to 10:30, what is the expected average traffic here? It has enough data to give me that prediction. Everyone okay with this? So using this data, many countries and their cities, along with the city traffic, are able to manage the traffic lights, are able to manage the traffic. Okay, can you guys go through this? In Sri Lanka, guys, when things get really bad, or when the policeman knows it's now getting into rush hour, what does he do with the traffic lights? Sorry? He switches it off and he manually comes and manages it, right? In certain countries, right, if you go to Malaysia, guys, you rarely see the policeman. In Malaysia, I mean, when I went there, I'm like, there's no policeman at all. There are all cameras and the traffic lights are computer controlled. So depending on the rush hour, the traffic lights change. Now here in Sri Lanka, when it gets come to rush hour, the policemen generally off the traffic lights and they come to the junction and they manually operate it. Okay, that has nothing to do with the computer system. But in certain countries, guys, okay, the traffic lights are controlled by computers. So depending on the hour, it changes the timing for each traffic light. Now in Sri Lanka also at certain hours, certain roads are one way only. You guys would have seen this, right? So what does the policeman do? He comes and puts traffic cones and blocks vehicles from entering the road. It happens manually. But in certain countries, when it becomes one way, automatically they have an LED board. The LED board will automatically show the message saying it's one way. Nobody can enter the road now. You get my point, guys? Okay. That's traffic management and urban planning. Okay. Then guys, can you all read the third one? I have a slightly long video to show you all over here, but you all have to see it, I think. Can you guys read utility infrastructure first and optimization? Okay, everybody. Now, even if you're at home, you're with your smartphone, location is being tracked. If you choose to walk out, many of us, we go out with our smartphones and our smartphones are tracking our movements. So even when you walk, your movements are being tracked. When you get into a vehicle, again, you have your phone. Also, guys, many of us now we have the stereo player that has something called Android Auto or Apple Play. Have you guys heard of this? We say CarPlay. Okay, basically your stereo setup can now connect to your smartphone. So now Google has better tracking over you. So even while you're driving, it can track where you're moving. Is it clear? What's your average speed? Okay. Can you guys keep reading it? Have you guys seen the latest feature on Google Maps? When you say, I want to go from Kohuwala to Dehiwala, and when you start the journey on the map, have you all seen an exclamation mark appears? To report stuff. So you can report policeman ahead. You can report accident ahead. You can report object has fallen on the road ahead. You can report what you call crowd ahead. So other drivers who are taking the same route, they are automatically informed of it. Like especially when you're traveling outstation, notification comes, police ahead. That's so convenient for you. Okay. That's so convenient. And then sometimes if there's an object ahead or traffic ahead, multiple people have reported it, automatically Google changes your route. Says we are given you an alternative route since many reported object ahead and traffic was reported. So it makes life a lot easier for you. This is an example of big data, getting data from multiple users and then making a decision for you. It's optimizing your route. Okay. You all read that. I'll load this video. Okay. It's a bit long, but I think we should watch it. How Google remapped the world. Eight-minute video.
And ingrained itself.
Okay, I'm going to just do a quick example over here. If I were to come over here and type, I'll just type cafes close to me. I don't know, I have given my location on what? So not bad, huh? Maharagama, it's asking me for my exact location. Okay, I'll say use precise location just this time. Loading, 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 loading. Now, based on my location, it came somewhere close, not very close. Yeah, still now it has come to Pepiliana, Maharagama. It's now giving me cafes close to my location. Everyone okay with it? Okay, because it is tracking my movements. Okay, then because it's tracking my location based on where I am, then it starts promoting cafes. Okay. Right, everybody, let's move away from me. The rest of the video is not that. Can you guys come down to the next part? Transportation. Everybody, big data is also used in the transportation industry. Okay, everybody, boys. In addition to ensuring road planning is optimized to ensure roads and public transportation will be efficient, big data is used in a number of ways to improve transportation. Public transportation optimization. Can you guys read that? Okay. So by using big data to analyze passenger data, monitoring traffic patterns, route efficiency, route schedules can be adjusted based on demand patterns. Okay, listen all of you with me. Not always we have the same number of passengers. If we can monitor the number of passengers we have been having at different times for the last 1-2 years, we can then decide at what time should we release trains? At what time should we release buses? At what time should we not be releasing them? At what time should we be releasing AC buses? What time should, guys, I don't know, for some reason I got disconnected. Okay, let's try again. Okay. Anyway, can you guys go through that, guys? I'm gonna stop it after that. Can you guys go into fuel efficiency and emission reduction? Big data analytics is used to monitor fuel consumption, vehicle performance, and emission. This data helps fleet operators optimize fuel efficiency, reduce their carbon emissions, and comply with environmental regulations. And then, guys, we have safety management. Can you guys go through that? Using big data analytics, okay? Data relating to accidents, near misses, and other safety related incidents helps identify common risk factors and implement preventive measures. Are we all okay with this? These measures can be continually monitored to review their effectiveness. Okay. So all of you, big data can also be used to improve the safety on roads. Okay. By analyzing the data of how vehicles collided with each other, by analyzing how there were near misses, what were the common factors in these near misses. Okay. Right. Can you guys then come down to the last part? Fraud detection. Everyone okay with this? Think about your banking card, guys. Every transaction you make on your card is recorded on a computing system. Every single transaction you make. Okay, so when it comes to banking systems, guys, volume is massive. Velocity is massive. The data is changing so fast. So much of volume. All of you are with me. Okay. When it comes to banking data, a lot is happening over there. Can everyone read this? Banks, insurance companies, law enforcement agencies, organizations. Okay. So number one, guys, we can use big data to identify patterns. How do people shop? Okay. How do people make purchases? Okay. At what time of the year do they make most of their purchases? Okay. Can everyone read that? Big data analytics helps identify patterns of normal behavior within large data sets. Okay, deviations from these patterns can signal potential fraud. So for example, guys, you are normally using your card to make purchases in Sri Lanka. Okay, that's what the system has noticed. You're always making purchases in Sri Lanka. Now suddenly you make a purchase in China, immediately what happens? The bank is notified and the bank will then call you and ask, did you make a purchase in China? Okay, your card was charged by a seller in China. Was it you, or has your card been stolen? So then you say, no, it was me. I made a purchase on AliExpress. Okay. And you verify the purchase. Everybody okay with this? It's not like somebody is sitting at the computer and looking at the screen and waiting. No. When this unusual activity takes place, immediately whoever is on duty at that time is notified. Then that person's job is to call and inform you. Okay. Can you guys go through this? Sometimes the bank will automatically block your card. The moment they detect something unusual happening on your card, immediately card gets blocked. And then you have to call the bank and say, no, that was my activity. I did it with my own knowledge. I'm aware of it. Please unblock the card. Okay, can you guys keep going through? Then you can use big data to understand customer behavior. Okay. Can you guys read those? I don't have any videos, short videos for this. Okay. Okay, then we also use big data for real-time monitoring. Okay. So guys, when it came to applications of big data, we spoke about the health industry, we spoke about transport, we spoke about fraud detection or financial organizations, and the fourth one was what? Infrastructure planning. Okay, these are the 4 examples we said. Are these the only 4 examples? Obviously no. There are many other places where big data is being used. Okay, these are simply a few of them. Everyone okay with this? Everybody, can you go through this? If you guys, I'll just give you all one quick example before we take a break. if you look at this, I'll just take getting so annoying right now. HNB card promotions. Okay, just check this out. Okay, how the bank plays with you. Okay, so if I come to let's take supermarket. Supermarket is a good example I can take. So you look at how HNB is playing with you. So if you come to card promotions, they give you offers based on the card you have in various categories. Okay, so I'll go with shopping. So if you come over here, let's take SoftLogic Willow, 25% off above 7,500. Sounds like a pretty good deal, isn't it? Let's open it up. Okay, so now what do they say? Get 25% off on bills above 7,500. So do you think 7,500 is a random number? No, there is definitely data behind how they came up with 7,500. Okay, they would have noticed customers are shopping only for 5,000. We need to increase their spending now. Make the minimum bill amount 7,500. Okay, then you get 25% off. Sounds awesome. Okay, but be careful. It's only on the 15th and 29th. Okay, be careful. It's only between 3 p.m. to 8 p.m. Okay, so 15th and 29th, 3 p.m. to 8 p.m. only at these locations. Okay, I think these are all the branches. SoftLogic doesn't have a lot. Okay, but be careful. Maximum discount will be 5,000 rupees per day. Okay, so that 25%, maximum how much? 5,000. Sorry, maximum 5,000. How many transactions? Only one you can do. Discount is excluded on all these items. Okay, so if you buy milk and eggs and all that, discount doesn't apply to them. Okay, okay, that was my exact reaction when I also was reading it. What is this? Okay, maximum quantity, you can buy maximum 5 kilos of an item or 5 units of an item. Okay, so this data that they came up with is so not data, man. These numbers that they came up with, okay, is backed by big data. They have been collecting so much of data. Now they have seen, okay, what is the best way we can make money out of this? Okay, by telling them minimum you have to shop for 7,500. Minimum you have to do this. Minimum you have to do that. Okay, and then they have their terms and conditions all over here. Sorry. Yeah, so sugar, flour, rice, coconut, liquor, tobacco, all that is out there. Okay, so yeah, interesting. Okay, so this is one simple example of how banks would come up with an offer. These are not random numbers. These are numbers, or these are conditions that are backed up by data. Okay, right, guys, I'll give you all 15 minutes. We don't have time for questions. When you come back, guys, I'll explain the instruction. Right, everybody, let's have a look over here. Guys, page number 25 of part 1. Page 25 of part 1. Can we have a look there? It says here, a student is registering at a tutoring website for AS and A-level subjects. Figure 1 shows part of the web page for registration. So you can see the form over here. Complete the table to identify the type of validation required for each input item. Use each type of validation only once. So for name, guys, what do you think I should put there? Tell me again. Presence check. Okay. We are going with presence check, guys. Do you all agree with them? You can use each validation rule only once. So do you think, shall I keep that for password? Each validation check I can use only once. So I'll keep presence for password. You have to fill the password. And for name, shall I put length? Okay. Otherwise, for password, what are you going to put? Okay. You understand what I'm saying, Preeta? Okay, there. So for name, I'll put length. And for password, I'll put presence. Okay, otherwise I will not be able to repeat it now. So for name, length check. And for password, I'll put presence check. Presence check. Okay, can you all just underline what gave it away? For program of study, user has to choose one of the values. Lookup, you can say. Lookup validation. Okay. Lookup validation. For subject, list validation, because new values could be added to it, isn't it? Lookup is generally used for values that don't change over time. So you can say list validation over here. New values, new subjects may come in here. For credit card number, Format check is good. Check digit is also good. Why will I not take format? For postcode, I'll keep format because they told me here use each validation only once. So I'll keep format check for postcode. I'll keep format check over here. And I'll keep check digit over here. The last digit of your credit card number is generated using a formula that is applied on the remaining numbers. That's what you call a check digit. Then can we move on to part 2? Let's do a entity relationship diagram question there. That might take some time. Everybody, part 2, please. Okay. So I'm closing this up. I'm saying close, and I'm going to go into part 2. Okay, so over here we have topic 12, part 2. Let's open it up and let's scroll down to an entity relationship diagram question. What do you think about, we'll do this, Philo. Page number 21. A bicycle hire, page number 21, everyone. A bicycle hire company operates a rental scheme in a city. Bicycle that they give out on rent. Cyclists must register to use the rental scheme. Okay, I'm just going to highlight whatever entity I see. Okay, so I think bicycles are going to be an entity. I think rental will be an entity. I think cyclists will be an entity. Bicycles are placed in lockable racks around the city. Do you think city might also end up to be an entity here? Okay, it looks, I don't know. I'm just assuming. It seems like we will have various cities also. Cyclists use a phone app or website to book a bicycle at a particular location. I think location and city will be the same thing, no? If you want, highlight location also. But I think the location and city will be the same thing. They are sent a text message with a lock code to release the bicycle. A member can book more than one bicycle on any day. Now a member came. Cyclist and member would be the same thing, no? Cyclist and member would be the same thing. I'll just highlight it, but cyclist and member are going to be the same thing. The bicycles are inspected and serviced once a week to maintain safety of the riders. Design the tables for a relational database for the system. The solution should be in third normal form. Use a single line parenthetical notation. Do not draw a diagram. So everyone, how do we get started here? Do we need to indicate what is the primary key, foreign key, all that? No need. Okay, but we need to show how the tables are connected to each other. So it's not exactly an ERD. Lisa, are you with me? This is not 100% entity relationship diagram because we are not showing primary keys and foreign keys, but we have to show the relationships. So shall we start off with the individual tables? The smaller table like what? The most obvious one would be cyclist. Shall I call it member or cyclist? Member, no? So I'll do a draft first. So I'm going to have a member table. Member TBL. I'm just doing a draft now. Give me the fields. Member ID, MEM_ID. Then I'll say name, but you know, right? It has to be first name, last name, like that. Okay, we'll do in the proper way. We'll do first name. What did you say? You will also need to record the contact number because what gave you that idea? Because they said cyclists use a phone app or website to book a bicycle at a particular location. They are sent a text message. So then we need contact, member contact. They are text message, no? They didn't say via email, no? So member contact. Right, we do know that. Any other table that you can think of? Billing. Instead of billing, don't you think it should be called Rental, no? So before rental, what is the other table you need? Bicycle table, no? You would need a bicycle table to store, a list of where all our bicycles are. So here I'll just put BIC ID. Anything else? Careful. The members don't own the bikes. He's saying to put location. What do you think? Location ID, isn't it? Don't you think all the locations will be in a separate table? So I'll keep it. I won't put anything now. For now, just give me the basic. Maybe the bicycle ID, the bicycle model, bicycle color maybe. Those are the attributes we'll have of a table of a bicycle now. Okay, bicycle brand or model underscore model. Sorry, brand and then model. Okay, brand and then maybe the model. Okay, right. Then guys, girls, you will obviously have, when a member takes a bicycle, you have a rental table. When a member takes a bicycle, you have a rental table. So every rental will have a rental ID. Rental ID. Next, every rental will have a cyclist who takes the bike now. So you need to have the cyclist ID. Say with me. Not cyclist mean members ID you need to have now. Members ID we need to have. Every rental will have a member and every rental will also have a bicycle. Bicycle ID. Anything else you think we need to record here? So he said put location in the bicycle table. You're saying to put in the rental table. In the rental table, it makes more sense, no? 1 second. Okay. So you're saying to put location ID. Lock ID. Location ID. Shall I also store the code of this rental? Is it necessary? The code of this rental, for every rental, there is a code that is sent, no? They are sent a message with a lock code to release the bicycle. We need to know that, right? What was the code? So we'll also record the code. Okay. In the rental table, what was the code that was used in this rental? Okay. Right. So rental ID, member ID, bicycle ID, location ID, and what was the code used for this particular rental? Payment. They didn't talk about anything about payment here, no? Nothing about payment over here. If you want to put cost, you can put cost here, but they didn't talk about it to me over here. Okay. Will you lose marks for not putting cost? I really don't think so. Okay. Of course, we need the date. Everybody, it doesn't matter. Date has to be there. When you draw your final diagram, let's keep date at the beginning. Okay. Of course, we need the date. Right. Any other table that you think should come here? So I'll put a tick here. Bicycle I created. Rental I created. Cyclist I created. Location table, no? Location TBL. Every location will have an ID. Every location will have a name. Okay. So we'll keep it like that. Location ID, location name. So I have a table for location also. Member also I have. Anything else? Service. I need a service table. Okay. Service table. What do you think would be the fields over here? We'll go with service ID first. Every service will have a unique ID to identify it. Service ID. Then the bike that was serviced. Bike ID. The date that the service took place on. Okay. Yes, it should be. So we should put serve underscore date. No, that's correct what he's saying. Okay, so SCR underscore date, service date. Did they talk about any employees or technicians handling this? So we don't have a separate table, no? Girls, all of you agree with me? Yeah? If they now, I remember last week we did a question about Equipment. What equipment? C equipment. In that they mentioned technicians are there. So then we had a separate table for every technician. Here there is no mention of a technician. Can you guys turn the pages, go to the marking scheme and see how is it? Can everyone have a look at the marking scheme and see whether it's different from what we did? Bicycle lock code, in which table is it going? In the bicycle table. The code is being stored in the bicycle table. In the bicycle table, the location is being stored, not in the rental table. Oh. Sorry? Service person. We didn't add that. You can add service person. Okay. Can you all read the notes that the examiner has given you all? What do we cut marks for and what do we give marks for? Can you all read that? He would have specifically mentioned, right? Can you see if you have scored your marks for what he has said to give marks for? I'm going to scroll down now. Question number 6. Everyone read question 6 with the 6. Examiner has said 2 tables identified by suitable names for a maximum of 2. For a maximum. What? 2 tables identified by suitable names. We have that now. 2 tables with suitable names for a maximum of, I didn't understand that. Anywho, primary. Guys, can you go and label the primary keys then? Because I didn't do it because they didn't tell us, but apparently you have to also foreign keys also you have to. Okay. Okay, primary keys can we go and highlight, foreign keys can we go and, so we'll underline the primary key and asterisk the foreign keys. Everybody, this is not your final diagram. You all know that, right? This is only a draft. When you draw it, you have to show the relationship as well. So I'll just do it over here. Member ID, bicycle ID, rental ID, location ID, service ID. I'll put an asterisk next to foreign keys. If it goes in the bicycle table, okay. When you draw your final diagram, then put location in the bicycle table. Okay. You have to draw the here. Single line, not to draw an entity relationship diagram, but you need to show the relationships here. For a relational database for this system, the solution be in third normal form. Use single line parenthetical notation. So we need to show the relationship between the tables, right? Okay. I'm assuming no ERD, entity relationship diagram, but they are giving you marks for the primary keys and foreign keys also. No. We have to show the relationship also now. Here for relational single line parenthetical notation. Okay. Oh, maybe they don't. They just want to show which tables are connected. Is it one-to-many or one-to-one? That is not necessary here. Can you guys check the marking scheme? Do we need to show one-to-many, one-to-one? They haven't asked for that. No. Okay. So guys, we show the tables are connected, but what type of a relationship we don't need. Is it clear? Is it one-to-one, one-to-many? We don't need to show that because so that marks have not been given. Here just they have said use of notations across all tables. You have showed the tables are connected, but what type of relationship you haven't shown. Okay. By the way, all of y'all, if I put bicycle location in the bicycle table or rental table, I don't think it makes a difference. Are we all okay with that? Okay, it can be in the rental table, or it can be in the, so rental table means when the person goes and picks up the cycle, we note down the location he picked it up from. If you locate in the bicycle table also, it's the same thing. Okay. So I don't think it will make a difference. Okay, everybody. So I think our solution is okay. You all need to draw it over here. Okay. And you all don't need to show the relationship type, but you all need to show which table is connected to which table. So for example, member and rental will have a line. Bicycle and rental will have a line. Rental and location will have a line. Service and bicycle will have a line. Okay. Right then.